Hi, this series will be focusing on preparation of solid media, specifically for the purpose of bacterial culture and testing. And so, selecting appropriate culture media is critical because uh, we'll be testing varied species of bacterium. Some bacteria prefer special media for their growth, whereas some will grow in anything. Right. So, so think fast about which organism you are working with and why. How do we isolate it? And how do we go about performing AST, also called the antimicrobial susceptibility testing? This guide and this introduction and this series will illustrate how to match media to your bacteria. For example, Neisseria gonorrhea, E. coli, Staph aureus, and Bacillus subtilis we'll take as example and test purposes because we had expertise in our case in that area. And we'll also throw in some real life examples and lab experiences. And this I ideally targeted towards graduate students and professional, and also who is setting up their laboratory, that is our new researchers. First of all, you have to know your organism. Let's take a simple case: fastidious and non-fastidious. First of all, what is that? So fastidious bacteria shows a slow growth rate, and non-fastidious show fast growth rate, which is just a major difference. And fastidious bacteria always require a specialized nutrient, that is, it requires a selective media. And also, while choosing medium to grow in, the simplest way is to go through this CLSI and UCAST guidelines and their booklet. It will always suggest for this bacteria we have to use this media and this agar media. So also you can find it in ATCC if you are in America, and MTCC if you are based in India. That place where you purchase, that does ATCC, basically they will provide you control strains and certain pathogenic strains of population in a certain region that can also be found. Right. So while you purchase it, you can they have given information on the suitable media for that organism, for Staph aureus, for all kind of bacteria we have. So you can refer there too. So first of all, you have to match the media to organism's physiology. These are the easiest ways to do, and you can follow CLSA, UCAST, or ATCC protocols. Right. For example, Neisseria gonorrhea is fastidious, and E. coli and Bacillus subtilis grow on general media. So the Neisseria gonorrhea is a picky bacteria and requires enriched media, usually prepared by heated blood agar, and it requires anaerobic condition. So we incubate it usually in a CO2 incubator, right? And temperature is standard. And what is this heated blood agar? Heated blood agar will show a characteristic chocolate color. So that's why you call it, because they need a growth factor and heme, which is released by heating the blood, right? So they grow in that agar, whereas E. coli and Bacillus subtilis grow well on a standard nutrient agar like urea broth. Ludi agar or Mueller-Hinton agar. Mueller-Hinton agar is a specialty agar. So specifically used in antimicrobial susceptibility testing, uh, routinely used in clinic, right? So decide whether you are simply isolating a pathogen or testing antibiotics. So the media selection depend upon these two factors. If you are simply isolating pathogens, you need a different set of media, and we'll look at that in just a minute. So consider the test purpose, identification versus AST, and just media choice accordingly. And then use selective or enriched media when needed. For fastidious pathogens, just as we discussed now, a lot of factors. So for Neisseria gonorrhea, Thayer-Martin agar, a chocolate blood medium with antibiotic to suppress the other flora. So Thayer-Martin agar has a chocolate blood medium, means it doesn't have chocolate. Rather, the blood is heated in such a fashion that releases heme that gives you a characteristic chocolate color. So it's basically Thayer-Martin agar, and it has antibiotics like colistin and others to inhibit fungal growths and other bacterial invasive bacterial growth, to make it specific towards Neisseria gonorrhea species, and in some cases Haemophilus, to make it specific towards Neisseria gonorrhea. If you culture Neisseria gonorrhea in practice, so you should always request a selective chocolate agar and a CO, and you have to make sure the CO2 incubator is present beforehand. Similarly for Haemophilus species, they also need a chocolate agar. So the clear communication here is important with lab personnel about this needs is essential, and so if you don't inform them, you will end up blaming your students then. So for fastidious pathogen, use selective enriched media. Here only example is given for Neisseria gonorrhea, so just to show there is a selective media. So Thayer-Martin is basically Mueller-Hinton plus 5% chocolate blood plus antibiotics to inhibit contaminants, generally found in clinical settings. Inform lab staff of special requirements and storage conditions. You'll see that. So here's the illustration of a chocolate agar. So the hemoglobin provides the X factor hemin. So if not X, 10 factor 10. Hemin, growth supplement example is Isovital X is a product name, which provides basically NAD, vitamins and amino acids, and antibiotics to inhibit the growth. And here you can see this example. If you want to have a you're not seeing a colony here, just giving an example of chocolate agar and also spore spreading technique. And the student has taken a bit large amount of inoculum initially, so it depends upon what is the aim. If you want an isolated colony, then you can go for a proper technique, right? Let's move on. So standard AST medium is considered Mueller-Hinton agar. So Mueller-Hinton agar is generally used, or we can call it MHA. It has specified pH, and it is recommended by CLSI. Its in its formulation it has low in inhibitors, and pH is approximately 7.3, allowed good growth of common bacteria. It doesn't have specialized inhibitors like antibiotics in them. And what happens is that you can see here, so Mueller Hinton agar is a non-selective, non-differential medium. What makes it special is that it is loose. The agar is not so thick, and due to this, antibiotics can diffuse quite easily, depending upon various types of testing we do, like testing based on discs, testing based on wells, testing based on pore plating, right? So if the agar is quite loose, then the antibiotics can diffuse quite easily. And so the medium includes starch, so this is a key factor. So because of the presence of starch, any toxin that is produced by this bacterium are absorbed into the starch, and thus it doesn't interfere with your antibiotic being tested for susceptibility, and which was favorable to the testing community, so they made it standard, Mueller Hinton agar. So these properties made it gold standard for standardized antimicrobial disc susceptibility testing or disc diffusion. Or nowadays we use strip based EST. Okay, so MH supports growth of most non-fastidious pathogens, E. coli, Staph aureus. So it's important to ensure proper agar depth when you are pouring it. That is to how much? 4 mm is the depth, and pH, that is 7.2 to 7.4, to avoid skewing inhibition zones. So it will not be standardized. If testing non-standard organism, check whether a supplement like blood is needed. When you're testing the organism that is not standard or unique, or you have isolated something new, so you know in which the bacteria grows better, and it doesn't require supplements in your initial culture. So you can just transfer it here, like they've added for this chocolate agar, right? Just have a Mueller Hinton agar and just have the addition of a supplement for the bacterial growth. Okay, moving on. Next we have to adjust the media for specific antibiotics. The antibiotics has a lot of classes, and depending upon the mechanism of interaction with the bacterium, whether it is a DNA, whether it is a cell wall, based on that it is classified, and also the type, whether it is peptide based or not. Okay, some drugs require special media conditions. You can see the interesting case is in adaptomycin. They need extra calcium to be activated, because adaptomycin in physiological condition, while acting on our body, uses calcium to exert its effect. Basically, it will undergo a conformation change in presence of calcium, which enables the bactericidal activity of daptomycin towards antibiotics. So, towards a microorganism. Okay, some drugs require special media conditions. Example is daptomycin. So, stating with this case, you have to keep in mind the special condition required by the antibiotics to have a antimicrobial effect. So if you miss this Ca2 plus, and you'll be puzzled with or you will get a false results suggesting the bacterium is resistant, it's not responding towards the antibiotic, right? So you have to keep in mind that. This is a very important factor. As example, the daptomycin E-test requires MAH with 25 to 50 milligram per liter calcium tubeless to match reference MIC. So always check CLSI, ECAST or manufacturer guidance. Okay. Each time for each specific species and antibiotics, and it keeps updating, so you have to keep updating your handbook of CLS and UCAST. So example, colistin testing is difficult in agar, again because it's a peptide and there is a issue in diffusion, so it is done by broth dilution. But here we are talking about solid media preparation, so I don't want to jump too quickly here, so we might see it later. So this is another example. So then use blood agar for hemolysis test. Okay, some species. So this is another case. Depends on the media. Means one aspect is to check for the test against antibiotics whether it is effective or not. Another is to check for the presence of the bacterial characteristics, right? So one of them is use blood agar for hemolysis. Hemolysis is a characteristics of a bacterium and of a pathogen. So blood agar, example, 5% sheep blood. So in this case, the 5% sheep blood, when you add it to a media, you will add it in a condition that is suitable for the blood. Means you will not heat them. As soon as you bring the agar mold out of the autoclave, we will not add this sheep blood, right? So we let it cool. As it reaches transition temperature, which will be around 45, I believe, and so at that point we will add it so that the sheep blood is not damaged. So right, this is the difference. In case of chocolate agar, it is heated to release the hemoglobin. Okay, then Staph aureus produces beta hemolysis. Means you'll observe clear zones around the agar or around the colonies in the agar. So this helps to distinguish pathogens. Example, differentiate beta hemolytic streptococcus or listeria from non-hemolytic species, right? So you can see here this just a comparison. So you can see here this is just a comparison of Staph aureus and okay, this is a comparison. Just a moment. Okay, first you can observe the colonies here. So in the middle is the black spot is a colony, and around it you can see a clear ring, right? So you can see the same pattern here and here. So this tells you the presence of hemolysis, so that the opaque agar plate is slightly becoming translucent in these areas due to the presence of hemolysis. Okay, in this case, in the secondary case, you can see these colonies, the golden colonies. Aureus comes from the word gold, right? So this is for S. aureus, which are in yellow. So it is surrounded by hemolysis, and this alpha beta Gamma, you can just refer to the literature. It depends upon how much area the hemolysis is happening, how vigorous it is occurring, whether it is alpha, beta, or gamma hemolysis. And you can see these colonies. Let me highlight it in red. This is S. epidermidis. This bacterium colony is S. epidermidis. S. epidermidis colonies growing on Columbia sheep blood agar. So it's a Columbian agar with added sheep blood in it. So they are not doing AST here, so they used they're not using MHA. Okay, so also you can use this test. So you can use this. We can use this test to differentiate between hemolytic and non-hemolytic species. Okay, now differential media for different mixed cultures. Okay, in mixed samples like stool that you usually get from the laboratory, McConkey agar is invaluable because why? It inhibits gram positive and turns pink if lactose is fermented. Okay, we have seen E. coli from fecal culture from hot pink colonies. So when you use selective differential agars to isolate targets, means you want specifically gram positive, or if you want gram negative, use McConkey, or if you want whether it's specifically gram positive, you use a high salt agar. Okay, right. So we'll just take example, a simple one for E. coli. We use McConkey agar for gram negatives. It selectively differentiates. But among gram negative, there are another classification, right? Lactose fermenter and non-lactose fermenting. Those that ferment lactose in this agar turns pink. Those that doesn't do that, like salmonella, will be colorless. Okay, there are other examples, and other than McConkey, there are other specific chromogenic UTI plates that specifically determines whether the pathogen is urinary pathogens, whether it causes UTI or not. So here you can see the beautiful pink colonies, and here with the same agar you will see colorless, right? So this will be E. coli and this will be some salmonella, but here we cannot be specific, just approximate. Then using this colony you further culture them, and we will further do the testing if interested. Otherwise we'll just report the differential. So chromogenic media for resistance marker. Chromogenic agar contains substrates and antibiotics for rapid ID. So like we just saw the change in color, and there are certain agar with embedded molecules that respond in the presence of certain enzymes produced by certain transgens, like for MRSA. So in the presence of MRSA, if resistant enzyme is present that digests antibiotics, so it will digest. So it will digest antibiotics and release the chromogenic compounds and precipitates, so which will precipitate into your colonies like this. So here you can see, just a minute, where's the pen? Okay, got it. Okay, here you can see the colonies turning. So it doesn't have a characteristic color, so it depends upon the manufacturer whatever color you will get it, which will be mentioned. And so this is specifically for rapid MRSA detection. It will just detect whether the species is present or not. It will not give you the dose which is therapeutically relevant, right? So as soon as possible, we want to see whether this MRSA is present or not in a day. So the purpose is that in this case. So you have antibiotic, which is hooked up with a chromogen. So with the enzyme, in the presence of enzyme, if in case of MRSA, it will cleave this antibiotic, releasing this chromophore, which gives you a blue color precipitate that is shown here, right? That is the mechanism going on, which you guys already know, and just keeping the audience broad. Okay, moving on, media storage and handling. So each type of plates that we get has a purpose of storage and specification of storage. So store prepared media as recommended often in 2 to 8 degrees Celsius, and the purchase plate, if you're not making on your own, which is a common practice. So special media like chocolate agar has limited stability, so we usually purchase in less quantities based on use. For example, we keep chocolate agar and chromogenic plate at 4 degrees Celsius. Even then, agar plates remain fully viable only about 4 to 6 weeks at 4 degrees Celsius. So label, it's quite expensive, so it's better to buy after planning properly. So label all plates with preparation time and use dates, and avoid heat or drying. And then what happens is that if drying occurs, the standard depth that we suggested, that 4 mm, will decrease, which will affect your EST results. And stored in sealed bags, so in upright in the fridge away from freezer vents. Some are light sensitive, so you cannot store in a normal refrigerator. So when ordering new media, check if it needs refrigeration or light protection, and always inform lab managers and students to avoid unnecessary hassle and contaminations. So agar plates are usually kept in 4 degree, and they are never frozen. So we never keep it below 4 degrees Celsius or 2 degrees Celsius. We never freeze them basically. So another case that I forgot is that what is that? We do. Okay, and the important thing is moisture. Before experiment, or for example during the preparation, we never pour the agar too hot, and in the case the moisture will occur. And the trick mostly we use is to just heat up the agar bed, so whatever excess moisture is present, it will just absorb. But it is recommended to do it in a very fresh plate. And right, so if moisture is not there, what happens is that whatever inocula that you press into the bed is easily absorbed into it. And So we will get good colonies like this, like you see here. Okay, you can see the colonies are spread out, and even here you can see a clear cut growth. But you can see another example. What happens? Yeah, this is another example. This is understandable because it is chocolate agar. Usually the growth is slow. So you can see this kind of patterns you'll get it. Here there is moisture present. And this is not issue, this is just undergrowth. Okay, so that is it for today. I'll try to make it a bit better. So basically you match a media to organism, whether it is fastidious or Arabic or anaerobic. Follow standard, use CLSI UCAS media guidelines always. Choose selective or differential media when needed. Communicate clearly, inform staff or any special media, supplements or storage requirements. And also keep in mind that we always use or always do transverse inocula in a laminar if you're working in a laboratory or college setting. But people also do it just without them. In that case, they have a well administrated a protocol. And also such institutions usually have a good filtration system, and the particulate count in the air is very low, and there is chain of command. So you cannot just because they are in clinics, you find them doing cultures just outside the laminar flow without any contamination. If you just try to repeat it in your own laboratory, it will not work, right? So if you can follow their protocol and sterile aseptic conditions for the entire lab, you can perform it, otherwise not. Okay, good luck, bye bye.